welcome back to my class in Analytic Geometry. We are done with the different forms of equation of a line, the different forms of writing the equation of a line. We have the general form or standard form, the two-point form, the slope point form, the slope-intercept form, and the intercept form. For today, we will take up perpendicular lines. When do we say two lines are perpendicular? And we have the following formal definition of perpendicular lines. Perpendicular lines, two lines, L1 and L2 are perpendicular. Written L1 perpendicular to L2 if and only if M1 multiplied by M2 equals -1, where M1 and M2 are the slopes of L1 and L2 respectively. In this definition of perpendicular lines, the two lines are denoted by L1, line L1, L sub 2 or line L2. And the slope of line L1 or L sub 1 is given by M sub 1. And the slope of L sub 2, line 2 or L sub 2 is given by M sub 2, the slope of the second line, M sub 2. And the definition says these two lines, L1 and L2, are perpendicular. And if they are perpendicular, this is the notation we use. We have two small lines that are perpendicular. L1 is perpendicular to L2. And the condition is that the product of their slopes, M1 multiplied by M2 equals -1. You notice that the definition of perpendicular line states that two lines, L1 and L2, are perpendicular if and only if it's abbreviated as IFF. You read if and only if the product of the slopes of the two lines equals -1. This definition of perpendicular line is an example of biconditional statement. And many of the definitions in mathematics are biconditional statement. This definition says that if line 1 and L2 if line 1 is perpendicular to line 2, then the definition says the product of their slopes equals -1. Line 1 perpendicular to line 2 implies the product of their slopes equals -1. If we start from the product of the slopes of the two lines, if we start with the product of the slopes of the two lines and the product of the slopes of the two lines is -1, then this implies that the two lines are perpendicular. And this is what is meant by conditional statement. The definition is equivalent to two statements. If the first statement is if line 1 is perpendicular to line 2, then the product of their slopes is -1. And the other statement is the converse of the first statement. If the product of the slopes of the two lines is -1, then you can conclude that the two lines are perpendicular. From this product, M1 times M2 equals -1. If we divide both sides by M1, we would get M1 we would cancel out from the left hand side. M1 will cancel out from the left hand side, or M1 divided by M1 is 1. Multiply by M2 is M2. M2 equals negative 1 divided by M1. Using this equation, we can also say that two lines L1 and L2 are perpendicular. Written L1 perpendicular to L2. If the slope of one line is equal to the negative reciprocal of the other line. If we know the slope of the first line, and the first line is perpendicular to the second line, then the slope of the second line must be equal to the negative reciprocal of the slope of the first line. The slope of the first line is M1 and its reciprocal is 1 over M1. And multiply that by negative and you get the slope of the second line. We will now take example of problem involving perpendicular lines, and we will sketch the graph of perpendicular lines. Consider the following problem. Find the equation of the line passing through negative 1, negative 3, and perpendicular to the line with equation 2x plus 3y minus 6 equals 0. As in solving many other problems, the first step is to identify the given information, because we will use this given information to solve for the unknown in the problem. And in this problem, the first information given is the point negative 1, negative 3. The problem says that the line whose equation you want to find passes through the point negative 1, negative 3. And the second information given is that the line whose equation we want to find is perpendicular to the line with equation 2x plus 3y minus 6 equals 0. This equation is the equation of the given line. And the equation of the given line is written in standard form or general form. And the unknown line is perpendicular to this given line. And the unknown line is passing through the point negative 1, negative 3. Now we let M1 be the slope of the unknown line. We let M1 be the slope of the unknown line, which I denoted by L1. And I will use M2 to denote the slope of the given line 2x plus 3y minus 6 equals 0, which I denoted by L2. Since the unknown line and the given line are perpendicular, they must satisfy the condition in the definition of perpendicular lines that says if two lines are perpendicular, if L1, the unknown line, and the given line L2 with this equation are perpendicular, then the product M1 times M2 equals negative 1. And from this equation of the given line 2x plus 3y minus 6 equals 0, we can solve for the slope M2 of the given line L2 by writing this equation of the second line in slope-intercept form. The slope-intercept form is given by the following. The slope-intercept form is given by y equals mx plus p. And to write this is the standard form or general form of the equation of the given line L2. And to write this in slope-intercept form, we must solve for y from this equation in terms of x. Y should be the only variable in one side of the equation. So we start by transposing 2x to the right hand side and we take the opposite sign of positive. We transpose negative 6 to the right hand side and we take the opposite sign of negative 6 and it becomes positive 6. So we have 3y. At the left hand side we have 3y. Transpose 2x to the right hand side becomes negative 2x. And negative 6 transposed to the right hand side becomes positive 6. In slope-intercept form, the coefficient of y should be 1. Therefore, we divide both sides of this equation by 3. To make the coefficient of y 1, we divide the left hand side by 3. And we divide the right hand side by 3. And 3 divided by 3 is 1, or just cancel out 3 from the left and we get y. We divide each term of the numerator by 3. We divide negative 2x by 3 and we divide 6 by 3. We have negative 2 divided by 3 multiplied by x plus 6 divided by 3 is 2. So this equation of line 2 in standard form is equivalent, the same as this equation of line 2 in slope-intercept form. This equation and this equation represent the same line 2, but they are in different forms. This is in general form, this is in slope-intercept form. And comparing this with the slope-intercept form of equation of the line, the coefficient x, m, is the slope of the line. And in here, the coefficient of x is negative 2/3. And this is the slope of line 2, the given line with this equation, and I denoted by L2. M2 equals negative 2/3 is the slope of the given line with the equation 2x plus 3y minus 6, which I denoted by line L sub 2. Now, using this equation, m1 times m2 equals negative 1, which is the condition that must be satisfied by perpendicular lines, we can obtain the slope of the unknown line L1, because the slope of the given line L2 is now known, and m2 equals negative 2/3. We have m1 multiplied by m2 negative 2/3 equals negative 1. And we can cancel out negative from both sides of the equation. If you multiply the left hand side by negative, it becomes positive. Multiply also the right hand side by negative, it becomes positive. Or simply just cancel out the negative sign from both sides of the equation. And we have 2 times m1 is 2m1. 2 multiplied by m1 is 2m1. Divide by 3 or over 3 equals positive 1. And from this equation, we now solve for m1. Multiply 3 by 1. At the left hand side, we are left with 2m1. 3 multiply equals 2m1 equals 3 multiplied by 1 is 3. Finally, we divide both sides by 2 to solve for m1. The coefficient of m1 should be 1. So we divide the left side by 2. And we divide the right hand side by 2. And 2 will cancel out from the left. We have m1 equals 3 over 2. The slope of the unknown line L1 is the negative reciprocal of the slope of the given line L2. The reciprocal of 2/3 is 3 over 2. And take its negative. The reciprocal of negative 2/3 is negative 3 over 2. And take its negative, you get positive 3 over 2. Now, we know the slope of the unknown line, and we know that the unknown line passes through the point -1, -3. And you recall from our past lesson that if the slope of the line is given, and one point on the line is given, you can find the equation of the line using the slope-intercept form. Using the slope point form. Again, if the slope of the line is given and one point on the line is given, you can find the equation of the line using the slope point form. That's from our previous lesson. And the slope point form is given by the following. The slope point form is given by this equation, y minus y1 equals m multiplied by x minus x1, where the point with coordinates x1, y1 is the given point with coordinates -1, -3. x1, y1 equals the given point -1, -3. And the slope m is the slope of the unknown line L1, which is m1 equal to 3 over 2. The slope is equal to the slope of the unknown line L1, whose slope is denoted by m1, and whose value is equal to 3 over 2. x1, y1 equals -1, -3 implies that x1 equals -1. And y1 equals -3. We substitute the values of y1, the slope m, and x1 into this equation, and we simplify the equation to write the equation in standard form or general form. We have y minus y1 is -3. Because y1 is -3, we write -3 in open close parentheses, negative, open parentheses, -3, close parentheses. Equals m is the slope of the unknown line m1. And it's equal to 3 over 2. Multiply by x minus x1. x1 is -1. Again, because x1 is -1, we write -1 in open close parentheses. We have 3 halves multiplied by x. minus x1. x1 is negative 1. Now we simplify to write this equation in standard form. We multiply the left hand side by 2. We have 2 multiplied by y, and negative times negative is positive 3. At the right hand side we have 3 multiplied by x. Negative times negative 1 is positive 1. Now we remove the grouping symbols by applying the distributive property of multiplication over addition. We multiply each term of this binomial. We multiply y and 3 by 2. Also at the right hand side we remove the grouping symbols. We apply the distributive property of multiplication over addition by multiplying each term of this binomial by 3. We multiply 2 by y equals 2y. We multiply 2 by 3 equals 6. Multiply 3 by x equals 3x. Multiply 3 by 1 by positive 1, we get plus 3. In general form, the equation of a line in general form is of this form. Is similar to this form, the equation of the given line L2, where the first term contains the variable x, the second term contains the variable y, and the third term is the constant term, and the right hand side is 0. To make the coefficient of x positive, we transpose 2y and 6 to the right hand side. You can also transpose 3x and 3 to the left hand side, but if you do that, the coefficient of the variable x would be negative. But it's better to have a positive coefficient for x. So instead, we transpose 2y and 6 to the right hand side. At the right hand side, we have 3x plus 3. Transpose positive 2y to the right hand side, take the opposite sign of 2y, and it becomes negative 2y. Transpose positive 6 to the right hand side, and it becomes minus 6. Equals, since we have transposed 2y and 6y to the right hand side, nothing is left at the left hand side, and we write it as 0. Now we combine the constant terms 3 minus 6, and we start the equation of the line in general form with the term containing x, 3x, followed by the term containing y minus 2y, and the constant term 3 minus 6 equals negative 3, equals 0. This is the equation of the unknown line, L1. 3x minus 2y minus 3 equals 0. And the equation of the given line, L2, is 2x plus 3y minus 6 equals 0. Now we will sketch the graphs of these equations. The equation for line 1, the unknown line, and the equation for line L2, the given line. And they should be perpendicular when we draw the lines. Before we sketch the two lines, we check if this point is a point on the unknown line L1. To the problem says that the unknown line L1, whose equation we found to be 3x minus 2y minus 3, passes through the point -1, -3. If the line L1 passes through the point -1, -3, then this point -1, -3 is a point on the line. And if this point -1, -3 is a point on the line, then the coordinates of these points, that is x equals -1 and y equals -3, must satisfy the equation of line 1, 3x minus 2y minus 3 equals 0. So we check that. At this point, the value of the abscissa x is -1. And the value of the ordinate y is -3. And if the line L1 passes through this point, the coordinates of this point must satisfy the equation of the line L1. That is, if we substitute the coordinates of this point, x equals -1 and y equals -3, into the equation of the line L1, then this left-hand side must be equal to 0. We check that. 3 multiplied by x. We have 3 multiplied by x. X equals -1. Minus 2 multiplied by y. Y equals -3. Minus 3 equals 0. We want to check if this left-hand side would be equal to 0. We have 3 multiplied by -1 is -3. -2 times -3, negative times negative is positive. 2 multiplied by 3 is 6, minus 3. And you can readily see that this will sum up to 0. -3 minus 3 is -6. -6 plus 6 equals 0. Hence, we conclude that this equation of the unknown line L1 must be correct because the coordinates of the point -1, -3 satisfy the equation of the line L1. Now, to sketch the graph of these two lines, we find the intercepts of the two lines. And we start with the line L1 with the equation 3x minus 2y minus 3 equals 0. To find, we start with the x-intercept. At the x-intercept, the value of y is 0 because the x-intercept is a point on the x-axis. The x-intercept is the point of intersection of the line and the x-axis. And any point on the x-axis, the value of y is 0. Thus, to find the x-intercept or the point of intersection of the line and the x-axis, you set y to 0 in the equation of the line. If y is 0 in this equation, we have 3x. If y is 0, minus 2y will go because minus 2 times 0 is 0. And we get 3x minus 3 equals 0. And from this equation, you solve for x. Transpose -3 to the right. We have 3x equals, take the opposite sign of -3, we get positive 3. And divide both sides by 3. And we get x equals, 3 divided by 3 is 1, or simply cancel out 3. 3 divided by 3 is 1. This point x on the positive x-axis is the x-intercept of line L1. In particular, the point 1, 0 is the x-intercept of the line L1. That means the line L1 with this equation will pass through this point 1, 0 on the x-axis. Now we find the y-intercept of line L1. At the y-intercept, the value of the abscissa x is now 0. Because the y-intercept is a point on the y-axis, and any point on the y-axis, the value of the first coordinate x or abscissa is 0. Thus, to find the y-intercept, you set x to 0 and solve for y from the equation of the line. If x is 0, in the equation of line 1, 3x will go because 3 multiplied by 0 is 0. And we are left with negative 2y minus 3 equals 0. And from this equation, we solve for y. I will transpose negative 2y to the right hand side. But you may also transpose negative 3 to the right hand side and then divide both sides of the equation by negative 2. But if you transpose negative 2y to the right hand side, you will divide both sides of the equation by positive 2. I will transpose negative 2y to the right hand side, we get positive 2y. And positive 2y equals negative 3. Divide both sides by 2. And 2 will cancel out from the left hand side. This implies y equals negative. Y equals negative 3 over 2 or negative 1.5. This is a point on the y-axis. In the y-axis at y equals negative 1.5, the line will pass through this point on the y-axis, or specifically at the point as x is 0 and y is negative 1.5. Or the point 0, negative 3 halves. I will use negative 1.5 as a reference for plotting the points in the Cartesian plane. So we draw the first line, L1, with this equation 3x minus 2y minus 3 equals 0. By plotting the intercepts, x is 1 and y equals negative 3 halves. We draw the line in the Cartesian plane. In the horizontal axis, we write x. So it is known as the x-axis. In the vertical axis, we write y. So the vertical axis is known as the y-axis. At the intersection of the two axes, we write 0 to denote the origin. And I use a 1 unit intervals. The x-intercept of the first line L1 is at the point x equals 1. This is x equals 1. Or the point 1, 0. And the y-intercept of line L1 is at the point y equals negative 1.5. This negative 1, negative 2. Negative 1.5 is halfway between negative 1 and negative 2. So this is the point negative 3 halves or negative 1.5. And they connect these intercepts with a straight line. This is the graph of the first equation, 3x minus 2y minus 3, or this is the unknown line passing through the point -1, -3. Now we sketch the graph of the second equation, 2x plus 3y minus 6 equals 0. And we start with the x-intercept by setting y to 0. To find the x-intercept, we set y to 0 and we replace y in the equation of line 2 with 0. If y is 0, 3 multiplied by y will go because 3 multiplied by 0 is 0. And we get 2x minus 6 equals 0. This is now a linear equation in one variable from which we solve for x transpose -6 to the right hand side. We get 2x equals positive 6. And we divide both sides by 3 to make the coefficient of x1. Sorry, we divide both sides by 2 to make the coefficient of x1. We divide the left hand side by 2. And we divide the right hand side by 2. And at the left hand side, 2 will cancel out because 2 over 2 is 1. We get x equals 3. At this point, x equals 3 on the positive x-axis, the line L2 will pass through. This is the point x equals 3. The second line will pass through this point. At this point x equals 3, but this point has actually coordinates 3, 0. X is 3 and y is 0. Next, we find the y-intercept of line L2 by setting x to 0. Because y-intercept is a point on the y-axis, and any point on the y-axis, the value of x is 0. So to find the y-intercept, we set x to 0, and we replace x with 0 in the equation of line L2. When x is 0 in the equation for line L2, 2x will go because 2 multiplied by 0 is 0. And we are left with 3y minus 6 equals 0. And this is a linear equation in y from which we solve for y by transposing -6 to the right hand side, and it becomes positive 6. And to solve for y, the coefficient of y should be 1, so we divide the left hand side and the right hand side by 3. At the left hand side, 3 will cancel out because 3 over 3 is 1. And at the right hand side, we have 6 divided by 3 is 2. So the second line L2 will pass through the y-axis at y equals 2. This is the point y equals 2, or this point has coordinates 0 and 2. Now we connect this intercept and this y-intercept and this x-intercept of line L2 with a straight line. And this is the line L2 with equation 2x plus 3y minus 6 equals 0. And you can see from this graph that the two lines are perpendicular. They form 4 right angles. From your course in geometry in high school, we know that if two lines are perpendicular, they form 4 right angles, and these are the 4 right angles, 1, 2, 3, and 4. This is the given line L2 with the given equation 2x plus 3y minus 6 equals 0. And this is the unknown line L1, whose equation we found to be 3x minus 2y minus 3 equals 0. For your practice, please do the following exercises. Find the equation of the line through the given point and perpendicular to the given line. In number 1, the given point is the point with coordinates 2, 0, and the given line has equation 2x minus y minus 2 equals 0. In number 1, you will find the equation of the line passing through the point 2, 0 and perpendicular to the line with equation 2x minus y minus 2 equals 0. In number 2, the given point has coordinates negative 2, 1, and the given line has equation x plus 2y minus 2 equals 0. In number 2, you will find the equation of the line passing through this point negative 2, 1, and perpendicular to the line with equation x plus 2y minus 2 equals 0. In number 3, the given point is 2, negative 2, and the given line has equation 3x plus 2y minus 6 equals 0. You will find again the equation of the line passing through the point 2, negative 2, and perpendicular to the line with equation 3x plus 2y minus 6 equals 0. For each of these numbers, 1, 2, 3, please sketch the lines in one Cartesian plane. In one Cartesian plane, you draw the lines for number 1. The given line with this equation and the unknown line. In number 2, you draw the two lines in one Cartesian plane. The given equation, the given line with this equation and the unknown line. And also for number 3, you draw the two lines in one Cartesian plane with the given equation with the given line having this equation 3x plus 2y minus 6 and the unknown line. For you to be able to check your answer, I give you the answers to these exercises. In number 1, the unknown line has equation x plus 2y minus 2 equals 0. In number 2, the unknown line has equation 2x minus y plus 5 equals 0. And in number 3, the unknown line has equation 2x minus 3y minus 10 equals 0. If you have question about the lesson today, please ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Cartesian, the channel of learning and pleasure. Or don't forget to ask your friends and classmates to subscribe to my YouTube channel, Art Cartesian. Thank you for joining me in my class today.